This tutorial is about adding load cases to a RAPT run. We're going to start with the RAPT run that we did in the tutorial introductory RAPT run, and that file would be included with the tutorial videos. So we'll open that, base run, and we go down on the left hand side to input where there are loads, cases and combinations, and we go to cases to begin with. The cases that will come as default are self-weight, initial dead load, extra dead load, and live load. Initial dead load and extra dead load are superimposed dead loads, SDLs. And the difference between initial and extra is that initial dead load is included with self-weight to form a combination case called the initial deflection case. And that is used to calculate incremental deflection, which is the deflection that partitions and brittle finishes experience. I'll explain more on that when we get to load cases for deflection under combinations. So all of these cases are applied loads, although you can add them as a moment or shear diagram, and you can also add moving loads. Be aware, if you're adding a moving load for live loads, that will calculate your for strength. It'll give you an envelope bending moment diagram, but it will not do an envelope deflection case. So we go to applied loads, and there are a number of different load types you can add. A line load, which is kilonewtons per meter. This is just an input you provide, and that can be tapered or otherwise. We can add a load, the full panel, the full width of the panel, in which case we just add a loading, which is a pressure in kPa. Or we can add an area load if the tributary width is less than the panel width. We can add a point load, bearing in mind that the point load is assumed to be applied on the effective width of the beam or column strip, and we can add a point moment anywhere along the effective width of the beam or column strip. For self-weight, that's automatically calculated, so you don't have to do anything there. And that line load is based on the geometry that you have defined for your layers, elements, steps, beams, and spans. In general, you can turn that self-weight definition from program calculated to user defined, in which case you then add the line load yourself. It's unusual you'd have to do that, so we leave that on program calculated. Back to cases. On our live load, we have to tick this box here, which tells RAPT that this is the load case to use for deflection. The reason for that is because we can add another load case. We right-click anywhere on this here and right-click and click Add Load Case, or we can click the plus button up here. We add a load case and we can select what load case we want. And RAPT allows you to add in an alternate live load. An alternate live load is another live load case that is used in combination with the self-weight and dead load SDLs to form a ULS combination. And RAPT will then find the envelope or the worst case loading between alternate live load and self-weight and SDL versus live load plus self-weight and SDL. So essentially it's an alternate load case. It's not added to live load. It is calculated as a separate combination. And you then select which of those cases you want to be the deflection case. So when I flick that on, the other one goes off. So you can only have one case, which is the deflection case. We can also define lateral loads. So if I define a wind load here or an earthquake load, if I select a wind load, for example, that will give me a number of factors. This is the ULS to SLS ratio if you're adding in wind loads as SLS wind loads. And we click OK, and we can then add that as a moment shear diagram under spans, and then for each of the spans we click along the spans and add our shears and our bending moments. So let's put in here, I'm just adding shears for now, we can add bending moments later. Go to the next span, and you can see here we're adding shears to our frame. So you would get these bending moments and shears from a global analysis to put into RAPT to run as part of the floor system. RAPT won't be, you cannot add a lateral load to the frame and then have RAPT calculate the frame as a sway frame. RAPT is only for vertical loads, but you can add the effect of lateral loads if you want to include that for your slab design. If you switch off, this is on under columns, if we go to columns, you can select whether or not the columns have a restraint. If you unclick the restraint and essentially you're saying it's a sway frame, because you're not, you don't have an actual lateral load applied to the frame, RAPT won't actually, there is no sway frame analysis. But the reason I raise this is just because having a lateral restraint here, if you have those switched off so that it is essentially a sway frame, RAPT will not allow any moment redistribution. So as soon as these are all crossed, there is no moment redistribution. If you say they are braced by some stiff core or something else, then RAPT will redistribute moments. And again, bear in mind that when you have that restraint, that changes the bending moment diagram as opposed to when you have a sway frame and you have loads applied. So that needs to be reflect what is actually happening in your structure. And we can also add earthquake load if we want in a similar fashion. So I don't want those for now. I'm going to delete those load cases, and now I will look at our combination cases. Our combination cases for ultimate strength are based on the code load factors. You can change them if you want, but they are initially based on the code. Then you look at short-term service. Short-term service combination is what is used for crack control or for calculating crack control reinforcement. Permanent service and characteristic service are European specific, Eurocode specific load cases, also for calculating crack control reinforcement. Your deflection load cases, this is what I was alluding to before. When you calculate your deflections, you have to put in an initial deflection. Your initial deflection is your self-weight plus your initial dead load, and that is what is used to calculate your incremental deflection, and I'll explain that as follows. So RAPT will calculate your short-term deflection at 28 days, assuming no creep or shrinkage. It'll then calculate your long-term deflection, and your long-term deflection is your permanent deflection with long-term properties minus your permanent deflection with short-term properties. So effectively it gives you your long-term component of the load plus your short-term deflection. That gives you your total long-term deflection, including the elastic deflection at the end of 30 years for this to account for this 0.7. Incremental will then take that load case that I just explained and subtract your initial deflection. If you go to the help menu by clicking F1 right here and going to theory, it'll give you explanation in great detail if you need more information. Transfer prestress is the load combination used to for when you do final stressing, and pre-existing is the load case used for a structure if you are adding reinforcement or carbon fiber strips to a structure that is already built. And so this is the load case that you are saying the structure is subject to when you are adding the strengthening reinforcement or carbon fiber. And that is essentially, in a nutshell, how you add cases and combinations.